We are covering integral calculus for the FE exam, focusing on the three main techniques you'll encounter: u-substitution, integration by parts, and using the table of common integrals in the NCEES Reference Handbook. Understanding these methods is crucial for solving problems in the mathematics section and in other subjects that use calculus, like fluid mechanics or dynamics. Let's start with u-substitution. This is your go-to technique when you see a function and its derivative in the same integrand. The core exam skill is choosing the right u. Look for an inside function. For instance, if you face the integral of 2x times the sine of x squared, the x squared is inside the sine function. Let's set u equal to x squared. The next critical step is finding the differential, du. The derivative of x squared is 2x, so du equals 2x dx. Notice that 2x dx is exactly the other part of our integrand. This is the ideal scenario. We can now rewrite the entire integral in terms of u, becoming the integral of sine of u du. This is a basic integral that evaluates to negative cosine of u. The final step is to substitute back, replacing u with x squared, giving a final answer of negative cosine of x squared plus the constant of integration, c. A common exam trap with u-substitution involves definite integrals. If you're given limits of integration for x, you must either convert those limits to be in terms of u, or you must substitute x back into your antiderivative before evaluating. Forgetting this step will guarantee a wrong answer. Next is integration by parts, which is used for integrating products of functions. The formula, found in your NCEES Reference Handbook, is the integral of u dv equals u times v minus the integral of v du. The most difficult part is deciding which part of the product is u and which is dv. For this, we have a life-saving mnemonic, LIATE. It stands for logarithmic, inverse trigonometric, algebraic, trigonometric, and exponential. You choose u based on whichever function type appears first in that list. For example, to integrate x times e to the power of x, we have an algebraic term, x, and an exponential term, e to the x. A comes before e in LIATE, so we must set u equal to x. Consequently, dv is everything else, which is e to the x dx. From here, we find du, which is just dx, and we integrate dv to find v, which is e to the x. Plugging these into the formula gives x times e to the x minus the integral of e to the x dx. This simplifies to x times e to the x minus e to the x plus c. The biggest trap here is choosing the wrong u, which often leads to a more complex integral. Stick to LIATE, and you will avoid this on the exam. Also, be careful with the minus sign in the formula. It's a frequent source of simple errors under pressure. Finally, and most importantly for exam efficiency, is using the table of common integrals. Before you even think about u-substitution or integration by parts, you must flip to the mathematics section of the NCEES Reference Handbook. The exam is not designed to test your ability to derive complex integrals from memory. It's designed to test if you can recognize a standard form and apply it correctly. You might see an integral like 1 divided by the quantity a squared plus x squared. Instead of trying a trigonometric substitution, you should immediately recognize this as a standard form whose integral is 1 over a times the arctangent of x over a. Your task on the exam is simply to identify the value of a from the problem statement and plug it in. The most common mistake is not checking the handbook first, wasting valuable minutes on a technique when a direct formula is available. Always check the handbook. Remember that a definite integral simply represents the net area under the curve between 2 points. After you find the antiderivative using any of these methods, you evaluate it at the upper limit and subtract its value at the lower limit. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.